Good morning. In this video, I would love to explain about the material properties, which is typically the stress-strain curve that everyone has to learn in the basis of civil engineering. So before I go to explaining the curve, I would love to explain about the stress and the strain first. So as you know, stress will be equal to force bar area. So this is like the amount of the force acting on one unit area. So maybe 1 unit in squared or maybe 1 unit feet squared. This kind of force we call it stress or pressure. For example, in the steel rebar, if we apply the force like tension, so we can calculate the stress dividing this tension by the cross-section area of the rebar. In this way, we can get the tensile stress acting on this rebar. The second is strain. So the strain will be equal to change in length divided by original length. For example, if this rebar, so this rebar will be a little longer. By this we can call change in length. So this is original length. This is change in length. So if we want to calculate the strain, we can calculate change in length by original length. In this way, we can get the amount of the strain. In this one, you can notice that the strain has no unit, or maybe it can be like inch per inch, it can be like feet per feet, it can be like millimeter per millimeter. So it also can be called unitless or maybe length per length unit. So in this curve, this curve is called a typical stress-strain curve. So if you see this curve, we will see the linear behavior in the first region of the curve. So we call this elastic region. In this region, the material property is like very linear. We call this one the yeast one. So the end of this linear point, the linear curve, we call this one as the yeast one. So after yeast one, the material property is no more linear, then it's called like the curve. And we call this highest point ultimate strength. So ultimate strength is like the maximum strength that a material can hold in the elastic region. We call this region elastic, we call this region plastic. So in plastic region, we can divide this region into two parts, which is strain hardening. Strain hardening is like the material is very strong and very non-linear. We can call it strain hardening. Then the second region we can call necking. So if I have to explain about the necking, you can imagine a rebar. So when we apply force continuously, this cross section becomes very small and it's very small compared to this region. So before it go to the friction, the cross section becomes very smaller, and then we call this region as the necking. After necking, the material go to friction, and we call this one called friction. So in this curve, we calculate the modulus of elasticity, which is equal to stress by strain. This is the slope of this region, y by x. So in this video, and explain about the typical curve of the stress strain curve of the material properties. I hope you can learn something from my video.